Hello everyone, welcome to CMD lecture of next module type of keys. Okay, so what are keys and how they functions? Okay, so what are these keys members and all these things we are going to study about in this session. Okay, we'll move to the PPT. So keys, okay. So keys is a, so first of all, what is key? Okay, key is a machine element. Okay, so you are going to use the machine element used to connect the rotating machine element to a shaft. Okay, so the machine is going to run. Okay, for that running the prime mover. Okay, for that prime mover there is a shaft. Okay, this shaft is connected without rotating with the help of a small element is called as the key. Okay, so next you can see here, so what is key there? I mentioned it is the machine element used to connect the rotating machine element to a shaft. This is the shaft, and this is the key. So it is always inserted parallel to the exit of the shaft. Okay. So you can see this the directions. Okay, it is always parallel and it is always placed at the end. Okay, it is placed at the exist of a shaft. Okay, a keyway is a slot in a shaft and hub of pulley to accommodate a key. Okay, so over here, okay, the prime or the electrical motors or they are run by the with help of pulleys or with the help of gear trains. Okay, so with that the shaft to that pulley. Okay, so it is being connected with avoiding the arresting the motion of the relative motion between the shaft and the prime mover elements or the gears. Okay, so keys are being used. Okay, so there is a slot. Okay, okay, this is in this slot we are going to place this key. Okay, so that is going to fix and that is going to have this friction fit with the tight fit with the shaft. Okay, so coming to next, we are having the types of keys. Okay. Sun key is there, saddle key is there, tangent key is there, round key is there, and splines are there. Okay. So there are different. Basically, we are having generally we are having taper keys and parallel keys. Okay. Taper keys and parallel keys. Okay. So we are having that also. So all comes together. Okay. So these are the types. In the sun keys, we are having rectangular, we are having square, we are having parallel keys, keep head keys, feather keys, and woodruff keys. In saddle keys, flat saddle keys and hollow saddle keys. And we are having tangent keys, we are having the round keys, okay, we are having splines. Okay, so as its name is indicating, they are being placed tangentially and they are looks like a round. Okay, so all these things being studied. Okay, let's see how it looks like. Okay, So we are having, coming to next, the sunk keys are provided halfway, half in the keyway of shaft, okay, keyway in the shaft, half, okay. So next, and half in the keyways of the hub. So it is going to fit, okay, for example, this is the uh, pulley, you can say a circular pulley. So here it is, we'll be having a keyway hub. Okay. So assume it as a circular kind of things. Okay, make it circular. Okay. So this is the keyway hub. Okay, we'll be having a pulleys, right? We're having pulleys. Okay. So here in this, we are having all this kind. Okay. So these are the keyways, and this is the keyway hub in the pulleys. So similarly, we are having rectangular keys, square keys. We are having keys nothing but square type. Okay. Parallel keys, give head keys, feather keys, and Woodruff keys. So next the kinds, rectangular keys. Coming to very first, rectangular keys. What it says, a key is a piece of mild steel inserted between the shaft and hub of the pulley. Okay. To connect these together in order to prevent the relative motion between them. Okay. So 1 in 100, this is 1 and this is 100. Okay. The taper is taken in a 1 in 100 on the top side only. Okay. So this is a deal with the diameter of the shaft and width. Here width is there and T for the thickness. Okay. Next we'll see. Square keys. Square keys, only difference is that difference between rectangular sunk keys and square keys, the width width and thickness are equal. Okay. So thickness are both are equal. So here W width is equals to thickness. Okay. It is D by 4. So whatever the diameter of the shaft is there divided by 4D. So both will be having the same thickness and width. Okay, you can see this in this figure. It is the exactly square shape. Okay, width as well as whatever the width is there, the width is there, and the same thickness will be there. So this is the thickness side. Okay. So hope you getting this one. Next thing. So parallel keys. Okay. So here it is the maybe rectangular or the square section informed in width and thickness throat. You can see this kind. It may be noted that parallel keys is a taperless and it is used where the pulley, gear or other mating piece is required to solid along with the. So it is being used with the all that kind. Okay. You can see this. Okay. So how it is being parallel? It is not a taperless. It is a straight one. Okay. Parallel or feather piece. Okay. So give head keys. Okay. So it is a rectangular sunk key. So what it says, it is a rectangular sunk key is there with, very important, with the head, okay, with the head at one end is known as keep head. So getting this one. So where it is provided? So what is provided? Why it is provided? It is usually provided to facilitate and removal of keys. Okay. So you can see over here, it's actually rectangular key. Okay, rectangular sunk key. Okay. So with some variations. Okay, one head. Okay, give head. Okay. So this kind. So feather keys, okay, this key is attached to one member of a pair and which permits the relative axial moment is known as feather keys. Okay, we are going to lock it over here. Okay, set screws are there. It is a special type of parallel keys. It is also parallel keys, but it's a special type where which transmit the turning moments, okay, and also they permit the axial moments. Okay. You can see over here, and so feather keys can move ahead also, and you can lock also, lock at a particular point with this, okay, with the help of screws. So next is Woodruff keys. Okay. So we can see this kind, okay, where it is being used and all this real-time applications we have shown. Okay, the Woodruff keys is an easily adjustable key. Okay. You can see over it is like a half move. Okay. Can we see like this? Okay. It is it is a piece. It's a piece from a cylindrical disc having a segmental cross section in the front view figure. So it is a cylindrical, it is say, okay, in that we are having a segment, okay, one segment. So this segment, this portion, okay, in the front view of the figure. So whatever the you are seeing is a, okay, like this. Okay. So this is the one kind. So key is largely used in machine tools and automobile concessions. Moreover, the maximum utility in the automobile concessions. So next is saddle keys. Okay, coming to next type. Okay, so saddle keys are there. Okay, we are having two kinds: flat saddle keys and hollow saddle keys. Okay. So flat saddle key is a taper key, okay, which fits keyways. Okay, you can see in the figure. Okay. So here it is the taper is 1:100. So like this. So here it is 1 means here it is 100. The taper. So flat saddle keys. So next is hollow saddle keys. It is being hollow. So hollow is also again a taper key only, which fits in the keyways in a hub, and bottom of the keyways is shaped to fit the curved surface of the shaft. So whatever this portion you are seeing, so this portion is going to fit in the shaft surfaces. It is made aligned. Okay. Alignment is exactly done with the as per the shaft. It is used as a temporary fastening in fixing and setting caps. So all these things it is there. Tangent keys. So as the name is indicating, here you can see these keys are placed on the tangent link. The tangent keys are placed at the right angles. Each key is to withstand the torsion in the one direction. It is going to torsion is going to attain on this withstand the torsion on one direction only, used on the large heavy duty applications. So round keys, so you can see over here, round keys or the tapered pin, it is also called as. They are circular kind. You can see this circular in cross section and fit into the holes, drilled partially in the shaft and partially in the hub. Okay. So it is going to fit in the shaft as well as in the hub. The main advantage is that will be drilled and drilled after the remaining parts have been assembled. So it can be done after all the processes. It can be lastly drilled or drilled after the remaining parts have been assembled. Other parts. Okay, splines, you can see this. Okay. So you can see over here the splines are used. They are made of integral with the shaft. So you can see over here they are made integral with the shaft. This is the shaft. Which fit in the keyways broached in the hub. So this is the keyways broach. So this is the hub portion. Spline such shafts are known as splined shaft. This is known as this splined shaft. Splined shaft are used when the forces to be transmitted is large. When the forces are there, too much forces are being acting in the machine parts. Okay. So in that, we are going to use these splines. Okay. So it is going to fit in these things, these splines. So proportional and in the proportional to the size of the shaft. So whatever the size is there, okay, gear ratio is there. On that only it is going to fit. Okay, hope you understood this concept of keys, and few more things are going to be displayed or studied in further classes. For any queries, feel free to contact me, and we are here for your supports. Okay. Thank you, one and all. Have a nice day. Happy New Year.